problem. We start from preference, go to preference, select structural, then click OK, preprocessor, element, add, edit, add. Let's select beam to node 188, OK, then close this and close this. Let's go to material properties, then we give a material model to structural, linear, elastic, isotropic. Let's give the value of Young's modulus of elasticity. In problem that value is 2 raised to 10 to the power 5. Then next value is Poisson's ratio. Poisson's ratio is here 0.27. Then click OK. Then close this tab. Let's give the section of beam, then common section. Here is a rectangular beam. The breadth of beam is 200 mm and height of beam is 400 mm. Then click OK. Click OK. Then I have to select a modeling. We have to create a model here. So create a modeling on key points, on active CS. Then I have to select a first point. The first point is always a 0 0. That's why I apply on 0 0. We have to give a second point where the value of second point is 2 meter here, but we have to convert the 2 meter in mm. So I take here 2000, then for as second point 2000, apply. Next third point is 4000, then apply. 4 point is 5000, on 5000, then apply. 6 point on 6000, 5th point on 6000, apply. 6 point on 7000, apply. And our last point, 7th point on 8000 mm. Then click OK and close the key point, and we have to create a line from this. We have to connect this point throttle line. Then select the lines, then straight line, and this to this, 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 and select last point. Then press OK. Then we have created a modeling. Now we have to move to meshing. Then I am selecting here mesh tool. Then we have to give a element size here. Let's select line. I have selected all lines which I generated here, and press OK. Just give element size how much you need. I give here 20 element size. That cuts my line into 20 parts. 20 parts. Let's cut the line into a 20 parts. That means the element on this line is 20. element on this line is 20. I cut line, the element size of line is 20 mm, sorry 20. Then go to mesh tool again. We have to mesh a line, then select a mesh, then select all lines, then press OK. Let meshing is done. Then we have to give a boundaries. Then define load, apply load, structural. We have to give a displacement here. Which point I have to give a displacement? Line generate. So the display here is in point. I have a beam, overhanging beam. Overhanging beam has two support. One is our hinge support, or another is roller. So I take a hinge support here and roller support is here. Let's give a support, which here is a form of displacement. I go to key point, here is a key point, and OK. The hinge support has all degree of freedom except rotation shade. The road shade is open for hinge. OK. Then key point and apply here, then OK press. And for roller support, rotation shade and UX is open, transactional X is open, and apply. Here is a roller support and here is our hinge support. Then we have to give a force and momentum. Then select a key point, then select a force. Which key point we have to give a force? On that we have to give a force of 12 kN. So we give 12 kN on from where can we give a force, which axis? The Fy, and we have to convert 12 kN into a Newton. Then I have to take a force of 1200 kN. The force is from upward to downward. That's why I take a minus. From upward to goes a downward side. That's why I have to take a minus sign here. Then OK. The force is going to move to downward. Then I have to give a pressure on beam. Let's select a box where which position I have to give a force. I have to select a force with the help of box. Let's select from here to here. There is a 40 elements available in that region. Then press OK. Then select node 2, load key 2, then apply. then give a force of 6 kilonewton. That's why I have to give here a 6 kilonewton UDL force, which convert into mm. That's remaining only 6 newton. So here is a 6 and here is a 6. I have to give a pressure at node I and node J also. Then here is a force apply on body, and we have to give a second force on that side. Let's select the box, then give it from here to here. And the count is also 40 from here to here, and then click OK. Here we have to give a force of 12 kilonewton. That's why I have give here 12 and here also 12. Then press. I have to press OK here. Then there is a force apply on here and here also, and close. And I have to go a solution, solve current LX. Okay, our solution is done here. Then close. We have to see a result. Then we have to go to a general processor. Then select a plot control, plot result, deformation result. We have to get here. The deformation is like that. From that axis to here, our deformation. We have to screen sky and form. Okay, that's our beam. That's our beam in isometric shape. That's the deflection over here. Then I have to find a XMD and DMD also. For XMD and DMD, we have to go element table, define table, and for XMD and DMD, we have to give a table, apply 6, apply 16, apply 19. Okay, then I have to close. Let's go to plot result. Let's go to counter plot, element line. Let's select a 16. Front view. Here is our DMD diagram. The maximum bending moment is 143.3 e raised to 8. So here is got our maximum bending moment. Let's get our XFD. Let's apply. This is our XFD, the shear force movement diagram. The maximum shear force is generated over here, which is 18,900 over here. Then nodal solution, the spotting trace, one nexus trace, apply. The one nicest trace is generate over here 5.5. Maximum trace is generate over here. And I